Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next module, problem number 24. Okay. Fluid mechanics, problem number 24. As usual, we first come towards statement. Guy Raf bending to drink. Okay. Guy Raf, dear students, if we want detail about this animal, we can Google this term. But here we are not concerned with the nature of animal. Okay. We are only concerned with the physics related activities. Okay. Whatever may be the exact pronunciation of this animal, it is less important. Okay. Giraffe bending to drink. In a giraffe with its head 2.0 meter above its heart and its heart 2.0 meter above its feet. Okay. So, dear students, here total height is 4 meter. Okay. We can say that head our brain is 4 meter, that is approximately 12 feet. It indicates this indicates that definitely this animal is not an ordinary animal. This is a gigantic nature, and this animal is of gigantic nature, and perhaps this animal may exist or not at present. Okay. That is to say, its height is 4 meter. 4 meter is approximately equal to 12 feet, and 12 feet is enough height. Okay. Dear students, height of feet above the ground is 0 meter because feet are on the ground, while heart, which is between feet and head or brain, is 2 meter high, and further 2 meter high is head. Okay, so from feet to head height is 4 meter, while from ground or feet to heart height is 2 meter. Okay. The hydrostatic gauge pressure in the blood at its heart is 250 torr. Okay. Dear students, we have many times dealt with the conversion factor between Pascal and torr. Okay. So, it is given. Gauge pressure in the blood at its heart is 250 torr. Assume that the giraffe stands upright and the blood density is 1.06 into 10 raised to the power 3 kilogram per meter cube. Okay. In torr or millimeter of mercury, find the gauge blood pressure. This problem has 3 parts. Okay. Part A, at the brain, the pressure is enough to perfuse the brain with blood to keep the giraffe from fainting. And part B, at the feet, the pressure must be countered by tight fitting skin acting like a pressure stocking. So, we have to find the blood pressure at 2 places. Okay. One at the brain and second at the feet. Okay. Part C is if the giraffe were to lower its head to drink from a pond without splaying its legs and moving slowly, what would be the increase in the blood pressure in the brain? So dear students, here part C is nothing but only the difference of part A and part B. Okay. While part A and part B are also quite similar, as we will see hereinafter. Okay. Such action would probably be lethal. Okay. Dear students, now we move on to solution. We know that, dear students, the first two we have described just conversion factors. Okay, we know that 1 Pascal is equal to 1 Newton over meter square, which is alternatively equal to 1 kilogram per meter second square, and this is alternatively equal to joule per meter cube. Okay. However, here we are not concerned with this last equivalent value. Okay. We are concerned only with kilogram per meter second square or Newton over meter square. Okay. Moreover, next conversion factor is that 1 torr is equal to 133.3 Pascal, or alternatively this becomes equal to 0.1333 kilopascal. Okay. Dear students, in this problem we will not have to convert torr into pressure, torr into Pascal. We will have to convert Pascal into torr. Okay. So when 133.3 Pascal is equal to 1 torr, then definitely 1 Pascal will be equal to 1 divided by 133.3 torr. Okay. So in our problem, conversion factor, that is 1 Pascal is equal to 1 divided by 133.3 Pascal will be used. Okay, 1 Pascal is equal to 1 divided by 133.3 torr. Okay, perhaps I have mistakenly said a little wrong. Okay. 1 torr is equal to 133.3 Pascal. Okay, then 1 Pascal will be equal to 1 over 133.3 torr. Okay, moreover, pressure in a fluid at rest varies with vertical position y. For y measured positive upward, P2 is equal to P1 plus rho g y1 minus y2. Okay. Dear students, we will solve our problem on the basis of this expression. Dear students, this expression, that is equation number 1, can be reshaped in another form. Okay, that is, what will be the altered or modified form of this equation? This equation can be written as P equal to P naught plus rho g h. Okay. Then what changes we will observe? We will see that P2 has been replaced by P, P1 has been replaced by P naught, and y1 minus y2, which is change in length, is replaced by height h. Okay, that equation can also work in solving this problem. Okay, however we use this equation, that is equation number 1, in solving our problem. Okay, now first we come towards part A, then we will come towards part B, and we will see that part A and part B are very, very similar. Okay, just a minute difference quite changes the result in part B. Okay, dear students, here for solving part A, we will use these values in equation number 1. Okay, P2 equal to P hat, where Hert is written as a subscript of P is equal to 250 torr. This is provided in the statement of the problem. Okay. P1 equal to P brain, where brain is written as a subscript of P is equal to sign of interrogation, that is P1 is to be found. We have to determine value of blood pressure in brain, that is P1. Okay. Moreover, density rho is equal to 1.06 into 10 raised to the power 3 kilogram per meter cube. This is provided in the statement. G equal to 9.8 meter per second square. This is not provided in the statement, but it is a physical constant and we know this value from very earlier classes. Okay. Moreover, y1 is equal to 4 meter, y2 equal to 2 meter in equation number 1. Okay. That is to say, in equation number 1, all values will be replaced by these two values. Okay. Dear students, actually, we know that height of brain from ground is 4 meter, while height of heart from ground or feet is 2 meter. Okay, so two relevant heights are 4 meter and 2 meter. Okay, so y1 equal to 4 meter, y2 equal to 2 meter in equation number 1 we get. Okay, what we get? 250 torr is equal to P brain plus 1.06 into 10 raised to power 3 kilogram per meter cube into 9.8 meter per second square into 4 meter minus 2 meter. This implies that from here, dear students, we will keep, because we have to find out value of blood pressure in brain, so we will keep it on one side and this term will be shifted on other side of equality, a sign of equality on other side of equation, and this positive sign will turn into negative. Okay. Here we have directly written this term after simplifying as 20,776 Pascal. Okay. Dear students, actually 4 meter minus 2 meter, it will become 2 meter. Okay, this meter into this meter will become meter square, and from here meter cube it will be subtracted. Okay, simply 1 meter will remain in the denominator. Okay, so our units will become kilogram per meter second square. Okay, after simplifying this term, that is 2 multiplied by 9.8 multiplied by 1060, this will take the form as 20,776. Okay, while these units meter square will be subtracted from this meter cube, so we will be left with the unit kilogram per meter second square, and this is alternatively equal to Newton per meter square, and this is alternatively equal to Pascal. Okay, so we have directly put this value after simplifying this expression. Okay, so P brain is equal to 250 torr minus 20,776 Pascal. In the next step, we have again converted it into torr by dividing this value by 133.3. okay, as I have stated in the starting of this problem. Okay, because in the starting of this problem we had shown that 1 torr is equal to 133.3 Pascal. So when so many Pascals are equal to 1 torr, then 1 Pascal will be equal to 1 divided by 133.3. Okay, so dear students, here we have converted Pascal into torr. So result has become 250 torr minus 155.85 torr. This implies that P brain alternatively becomes equal to 94.15 torr. Okay. Here we have solved our part A quite satisfactorily. Okay. However, it is our matter of discretion that we can convert this value in several other values. Okay, if we want, for example, dear students, this figure that is 94.15 can be written as 9.415 multiplied with 10 torr or 0.9415 into 10 raised to the power 2 torr, but it is just a matter of discretion, it is not necessary. Okay, now we come towards part B. Okay, for solving part B, we will substitute these values in equation number 1. Okay, what values? P2 equal to P hertz, where hertz is written as a subscript of P equal to 250 torr, just same as in our part A. Moreover, here P1 is not equal to P brain, rather here P1 is equal to P feet, is equal to sign of interrogation, that is P1, that is blood pressure at feet, P feet is to be found. We have to determine the value of P feet. Moreover, in the same way as in the previous problem, density rho is given as rho equal to 1060 kilogram per meter cube. Okay, that is to say, when 10 raised to the power 3 will be multiplied with this value 1.06, then it will become 1060. Okay, g acceleration due to gravity is a constant. We know y1 equal to 0, y2 equal to 2 meter in equation number 1 we get. Dear students, actually we are concerned with hertz and feet. Okay, so height of feet above ground is 0 meter. Okay, because feet are lying on the ground. Okay, while hertz is between brain and feet and is 2 meter above. Okay, so here two lengths are 0 meter and 2 meter. In the previous, in part A, we were concerned with two heights 4 meter and 2 meter. Okay, here we are concerned with two heights 0 meter and 2 meter. Okay, so y1 equal to 0, y2 equal to 2 meter in equation number 1 we get 250 torr is equal to P feet plus 1.06 into 10 raised to the power 3 kg per meter cube into 9.8 meter per second into 0 minus 2 meter. Okay, this implies that we will keep P feet, blood pressure at feet, on one side, and all this factor will be shifted on other side of equation, and here sign will change. Okay, but here, because dear students, this quantity is in minus, so on shifting on other sides it will become plus, positive. Okay, so P feet is equal to 250 torr plus 2076 Pascal. Okay, what is the difference? Difference is that in part A there was a minus or negative sign here. Okay, we move on to part A. This is okay. Dear students, you can see that 250 minus 155. But in part B we have come to see the situation where 250 torr plus 155.85 torr. Okay, this is the only difference in part A and part B. Okay, okay, 250 plus 155 plus 85. Okay, in part A there was minus sign, due to which this result had become equal to 94 about, okay. But here, because these two values are being added, so our result will become 405.85 torr, okay. To this extent, our part B has been solved completely and satisfactorily. However, it is a matter of discussion that we can convert this value in different shapes, okay. Dear students, we can write it as 40.585 into 10 raised to the power 10 into 10 raised to the power 1 torr, or 4.0585 into 10 raised to the power 2 torr, or 0.40585 into 10 raised to the power 3 torr, okay. This is just a matter of discussion, not a compulsory matter, okay. Now we come towards part C. We had already mentioned that part C is nothing but just it depends on part A and part B, and we have just to subtract two values. We have nothing to do anything else, okay. Part C, increase in the blood pressure in the brain is equal to delta P, okay. Dear students, the term delta is usually used to represent change, okay. So here delta P may be treated as P2 minus P1, okay. But here instead of P2 P1 we have used P feet minus P brain, okay. So subtracting these two values, we get the result 311.7 torr, and this can be alternatively written as 3.117 into 10 raised to the power 2 torr. This can also be written as 0.3117 into 10 raised to the power 3 torr, okay. This is just a matter of discussion, not necessary matter, okay. Next is a table which we have shown many times in our previous problems. Here this thing was used that 1 torr is equal to 133.3 Pascal, moreover 1 Pascal is equal to 1 Newton over meter square, okay. Now we move on to reference. Our reference book. Our reference book is Fundamentals of Physics Extended. Authors are Holliday and Resnick and Jarl Walker. Its publisher is Wiley. Its 10th edition 2014 or 11th edition having been published in 2018 has been used. Here chapter number 14 under title Fluids is our concerned chapter, and this problem has been enumerated at serial number 11 of the exercise given at the end of this chapter, that is to say exercise number 14.11, and this is the end of our problem, our module, okay.